New stuff today. Couple of things. Item number one, the Monday of Thanksgiving break, there'll be an announcement that publishes on the My Notre Dame page, the section that says announcements for this class. It'll be called like end of semester survey or something. In that announcement, there's going to be a link to a Google form for you to fill out to indicate whether you want to take a doubled high test score or do a chapter test retake. The last test for the semester was this chapter 5 test that we just finished. So you have everything you need to decide which one of those two options you'd like to go with. At some point during your break, sit down and think about that and decide which one you want to do and fill out the form. If you are electing to do a retake, you have to tell me like when you're going to do it and what test you're going to retake. Everybody cool there? Okay. So even though chapter 5 was the last test, we're going to continue doing stuff for the rest of this week and the week we get back from break. So any material that we cover during that time is going to be exam-only material. So you still have homeworks, you still might have a homework quiz, but there won't be another test. Any material that we cover from this point forward is going to be tested only on the exam. Is everybody okay with that idea? Okay. The last thing I want to say, so aside from your double or retake and a couple of stray homework assignments or a homework quiz, your grade right now is basically kind of where you're going to be kind of heading into the exam, short of a couple percent here or there from a double test score, or if you have a bunch of or any like future homework or whatever. I can't imagine things move much more than a couple of percent unless you have somebody that's like, I had all A's and then a 22 on a test that I retook. You could have a big move. I would say though that the Friday of the week we get back is going to be the last day I'll accept any outstandingly late or missing or incomplete homeworks from the past. So if it's one thing, if it's like the problem set from that weekend and that comes in late, whatever, that's not a big deal. But if you're trying to give me stuff from chapters 2, 3, 4, or 5 after the Friday we get back from break, no bueno on that one. Is everybody okay there? So if you have a bunch of missings or incompletes or stuff that still you're planning on getting done at some point, that point is coming quite quickly. That Friday we get back is going to be the last point for anything that's outstanding to this point, any missing assignments to this point. Is everybody okay with that idea? Okay. Very good. So today we're going to be starting chapter 7. So in chapter 7, we're going to be taking a trip back into, a land where geometry kind of matters a little bit more. Or at least is like much more connected to geometry than what we've been doing here recently. So recall, in geometry, if I have a right triangle and I want to solve that right triangle, we used SOHCAHTOA, right? Maybe in combination with the Pythagorean theorem and the fact that a triangle has 180 degrees in it, right? But what about a non-right triangle? You could be acute also. can't use SOHCAHTOA, right? You cannot. However, there are still tools that we can use to solve the right triangle, or to solve that non-right triangle, to find the missing sides and side lengths. So that's what we're going to be talking about here in chapter 7. If I have a non-right triangle, what can I do to solve it or find its area, or, that kind of stuff? Everybody's good with that? Okay. We can't do SOHCAHTOA, but we do have two tools that we can use. Those two tools are called the law of sines, which I'm going to abbreviate LOS, and the law of cosines, which I'll abbreviate LOC. So for non-right triangles, those are going to be the two tools that we have. Okay. So before we talk about what the law of cosines and the law of sines is, and really how to use them, I want to talk about when to use them. How do you know which one to use? Because most situations you won't be able to use either of them. You'll have to use one or the other, depending on the information that you're given. So that's where I want to start our discussion today. So the way that we're going to remember which one to use is we're going to use our situations from triangle congruence in geometry. So do you remember there were 5 theorems for triangle congruence in geometry? Does anyone remember one of those 5? They use 3-letter abbreviations for the most part. What? Side angle side is one of them. So what's going to be really important to us, since these are all like 3-letter abbreviations, is that we're able to look at the picture and identify what of the situations we're in. So in like a side angle side situation, the two sides we're given have to make up the angle we're given. Is everybody visually okay? We're going to need to be able to look at a triangle, like a labeled triangle, and decide, which one of these 5 situations have we landed in? Okay. So again, the side angle side, what you're looking for is the two sides that you're given make up the angle that you're given. Does everybody feel okay there? Okay. Does anyone remember another one of these? So their side-side angle is not a congruence theorem. What you had was called the hypotenuse leg, which is a special case for the SSA situation where the A is 90 degrees. Although the SSA situation is one that we will be dealing with, so let's do that. So it's easy to confuse these. What is the difference between the two? In the SSA case, one of the two sides is not part of the angle. Right? Do you guys see that? In the SAS case, the two sides make up the given angle. Very important that you're able to tell the difference between these cases, because the tool that we're going to use is going to depend on which case we're in. And we're just going to be differentiating our cases based on using our eyeballs here, right? Is that okay? So far, so good? You guys will stop me if we get too far. What's another one? Angle, side angle is one. Very good. So for angle, side angle, actually, no, come on now. Stupid machine. So for the angle, side angle situation, notice the side that's given is part of both angles, right? Notice that blue side is part of the green angle and the orange angle. That's our cue for angle, side angle. What's the other one that's going to be closely related to that? Angle, angle, side. Again, these two are easy to confuse. Again, need to be really careful. What is the difference between the two when you're looking at it? Yeah, where the side is at, right? In angle, side angle, the side is part of both angles. In angle, angle, side, the side is part of only one angle. Keep in mind that, like, the blue side could be there also, right? Doesn't matter which angle it's a part of, but it's only a part of one angle. Everybody so far so good? The last one, does anybody remember it? Did side angle side. We did HL, the special case of SSA. We had AAS and ASA. The last one is well, side angle angle is the same as angle angle side, right? Right, you can read them forward or backwards. Angle 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 is not congruence, because you could have this guy and this guy that all have the same angles, but they're definitely not the same triangle. Give you a hint. Side, side, side is the last one. And this one is the easiest one to identify, right? Because it's just, you know. Because how are you going to screw that up? identifying which one it is. Everybody okay with identifying the type of situation that we're in? Okay. So our law of sine situations are angle, side, angle, 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 side, and side, angle, side. And I'm going to put a little asterisk by that one because it's one we have to be very careful on. There's a little bit more to it than that one, than the other ones. For law of cosine, that's going to be side, angle, side. Put a little star next to that because we have to be careful there. And side, side, side. I'll put a star next to that one because that also has to be a little bit more careful. Everybody okay? So this is how we're going to decide which of our tools to use, at least initially. So far, so good. Everyone feel confident that you can pick out which situation you're going to be landing in and then which tool to use. Okay. All right, so now let's talk about what the law of sines is and how to start using it. Now, you guys tell me, do you want to see where the law of sines comes from, or you just want to be like, just give me the formula and show me how to use it? You tell me, which one of those two? Do you want to see like how we come up with this formula, or do you just like give me the formula and show me how to use it? That's fine, no problem. Okay, so the formula for the law of sines is built around the labels on a triangle. So on a triangle, we have 3 sides and 3 angles that all have a number associated with them, right? The way we're going to write the formula for the law of sines is built around naming the sides and angles of our triangle in a very specific way. If you screw up the naming of these things, you're going to screw up the formulas, and then you're going to get the wrong answer. So I want to go through here carefully the naming convention that we have to use for the sides and angles in order that we're able to fill in the numbers into the formula correctly. Critically important that you're able to do this. If you're not, it's going to be big problems. But so far, so good? Okay. We want to start by naming our angles. So I name my angles, or we're going to name our angles with capital letters. So let's name those angles A, B, and C. Now, to name the sides, I'm going to start with one of the angles. Let's say we start with angle A. I'm going to identify the side opposite angle A. That's this side here, BC. I'm going to name BC as the lowercase letter a. So that the side opposite the angle is named with the lowercase letter from the angle. Is everybody okay with that idea? I'm going to name angle, I was trying to grab this guy. I'm going to look at angle B. The side opposite to angle B is the side AC. I'm going to name that side opposite angle B as lowercase b. And if we look at angle C, the side opposite angle C is the side AB. We're going to name that side with the lowercase letter c. Does everybody feel okay on our naming convention? You're going to have to draw your own triangles and label your own triangles, and it's going to be critically important that you're able to use this naming convention effectively. If you can't do that, you're not going to have the numbers in the right places in the formulas, and you're going to get the wrong answers. Okay. All right. So from this picture, the law of sines states that sine of angle A divided by side A is equal to sine of angle B divided by side B, which would be equal to sine of angle C over side C. Everybody okay with the formula? I want to point out to you that this is really 3 equations in one. So we're only going to be using 2 parts of the formula at a time. So I can say, like, I might use sine A over A equals sine B over B. Or I might need to use sine B over B equals sine C over C. Or I might need to use that sine A over A equals sine C over C. So those are like the 3 different formulas that are built into this one equation. So everybody kind of see that. When solving one part of our triangle, I'm only going to ever be using one part of the law of sines at a time. So either the yellow piece, the blue piece, or the green piece. Everybody's okay? All right. Let's do an example. So in a triangle, angle A is 32 degrees, angle B is 73 degrees, and side C is 13 inches. We're asked to solve the triangle. Remind me again what the direction solve the triangle means. To find all the missing angles and all the missing side lengths. So our first step of any problem like this is going to be to draw a picture. So I'm going to start by drawing a triangle. And now I'm going to label it. What do I label first on my triangle? Angle measures. So I like to start on the left-hand corner and then name things in clockwise alphabetically. So I'll name A, B, and C. And now I'm going to label the side lengths. Remember, the side lengths are based on the angle measures. So which side should I label as side A? Should I label AB, BC, or AC? BC. Which side should I label B? AB or AC? AC. Everybody's good? And then obviously then AB gets labeled as side C. Everybody good with how I've labeled things? Now I'm going to fill in the measurements that are given to me. So I know angle A is 32 degrees. I know angle B is 73 degrees. And I know side C is 13 inches. So far, so good. Now I'm going to look at my labeled triangle and decide which of the 5 situations I'm in. So if I look, I have angle A, I have angle B, and I have side C. Which one of those situations was this? Is this angle, side, angle, or angle, angle, side? I know it's got to be one of those two because I have two angles. Those are the only ones with two angles in it. Angle, side, angle. I see that because the side C is part of both angle A and angle B. So that tells me I should be using the law of sines to do this problem. And then I'm going to just write a little list for myself that I need to solve for side C, or I'm sorry, angle C, side A, and side B. So I'll just put myself a little spot to write my answers. Now, whenever I have two angles in a right triangle, I can always find the third angle for free. How do I do that? Yeah, I know there's 180 degrees in a triangle. So if I do 180 minus angle B minus angle A, the remaining has to be angle C. So whenever I've gotten two of my three angles, the third angle is free. Don't find it algebraically, just do it the easy way. Everybody's okay? All right. So now I'm going to use the law of sines to figure out A or B. We'll figure out we'll decide in a minute which one we want to solve for first. But to use the law of sines, either I need angle A and side A, or I'm going to need angle B and side B, or I'm going to need angle C and side C. Which one do I have both the side and the angle for, A, B, or C? C, because I just found that C is 75. Everybody's okay with that? So we're going to be using that. Now, in the case of angle, side, angle, or angle, angle, side, the order in which you solve for your side lengths does not matter. So let's say, for example, we solve for side A first because it's alphabetical. That makes me happy. So to solve for side A, I'm going to write sine of angle C over side C equals sine of angle A over side A. Is everybody okay with how I filled in my equation? When I have an equation like this where it's one fraction equal to another fraction, what do we call that kind of an equation? It's a word from geometry. Starts with a P. It is a proportion. What is the technique we use to solve a proportion? It is cross multiplication. That is correct. Cross multiplication is a solving technique to solve a proportion. It is not how we add fractions, is not how we multiply fractions. In fact, it has nothing to do with operations on fractions. It's a technique for solving equations. I'm going to say cross multiply about 1,000,000 times this chapter. Don't confuse it with operations with fractions. Is everybody okay with that? Yes. All right. So I'll do A times sine 75 equals 13 times sine 32. Absolutely. To get the A by itself, what do I need to do next? divide by, no, sine 75, right? Well, don't do that. Everybody feel good so far? Now that the A is by itself, it is calculator time. Before I start typing things into my calculator, what should I check? The mode. What mode should my calculator be in? Degrees. And in fact, this chapter, we're always going to be in degree mode. So I've already changed mine, but you should check yours. To make sure that you're in degree mode. We'll be in degree mode for the whole chapter. You won't have to check again. So I've typed in 13 times sine 32 divided by sine 75. If I press enter, I get about 17.13. I'm sorry, 7.13. Everybody feel okay there? Were able, those of you following along, got it into your calculator okay and got the right number to come out? Great. Now we're left with is to solve for B. Now I have two sides of this triangle. Can I use the Pythagorean theorem to solve for the third side? No! Why not? Because the Pythagorean theorem requires a right triangle. Do I have a right triangle here? No, I do not. What am I going to do again? The law of sines. So, question for you before we go to the next step. Now I know angle C and side C, but I also now know angle A and side A. Which one should I use to solve for side B? My C stuff or my A stuff? Well, technically it doesn't really matter, but which one would be a better idea is to use our C's. Let me explain why. There's really two decent reasons. My answer for side A, I had to calculate. What if I made a mistake? If I use that number to do the next answer would be wrong if my answer for side A was wrong. Side C and angle C were given to me. Those aren't going to be wrong. I feel much more confident about using those than an answer I calculated. That's reason number one. Reason number two is that 7.13, that number, we rounded, right? We're not going to use the exact value of angle A, or I'm sorry, of side A in our calculation. That's a rounded value. So then we'll use that to get B, and then we'll round again. That gives us like 2 layers of rounding inside of one answer. For what we're doing in this class, that's not going to make a hill of beans a difference. But if you're working for NASA and you're trying to land a spaceship on the moon or something, you have an answer that differs in like 5 decimal places out. All of a sudden you miss the moon entirely and you go flying off into space and you get fired. Because it spent $1 billion to miss the moon. Oops. Okay. So I'm going to use my C's. So I'm going to say sine of angle C over side C equals sine of angle B over B. Everybody's good with how I set up my equation? What was this equation called again? Proportion. That's right. How do I solve that again? Cross multiply. You guys have been waiting all year to say this. What do I need to do to get the B by itself now? Divide by sine 75. And then it's calculator time. So I get about 12.87. Yep. Now, before I've solved the triangle, but before I'm done, I want to check something. I'm going to do a little check here. Now, the check I'm going to show you is not foolproof, but it should catch, if you've made an egregious mistake, it should catch it. So I remember from geometry, we had a theorem that said the largest angle for a triangle was across from the largest side. So 75 is my largest angle, 13 is my longest side. Okay, that looks good. That the medium angle was opposite the medium side. So 73 is my medium angle and 1287 is my medium side. That looks good. And then that the smallest angle is opposite the smallest side. So 32 is my smallest angle. That's opposite 7.3, my smallest side. I feel pretty good about my answer. Is this check foolproof? No. But if you do something silly like write your answer for angle or for side B where angle or where side A should go, it should catch that for sure. It'll catch a lot of silly things that you possibly could do just by doing that little check at the end. Now, it doesn't tell you where the mistake is, but it would tell you if you've done something egregiously wrong, like put your answer in the wrong spot or something. Should catch those. So far, so good? Okay. You guys feel relieved to be back to like something that resembles the mathematics that you're used to, where it's like, oh, all I'm doing is like solving and writing equations and solving them? This sounds much more to my liking than writing proofs and drawing graphs and like having to use the unit circle all over the place. Notice we're not going to do that at all. Yay! All right. Our second example says, in a triangle, if angle P is 43 degrees, angle Q is 80 degrees, and side Q is 7.3 centimeters, solve the triangle. Notice that I can tell the difference between side lengths and angle measures just from the degree symbols, even if I ignore the capitalization, or if it's like a letter like P where sometimes it's hard to tell if it's capital or lowercase. The units attached to the number should tell me. So I'm going to draw my picture. So start by drawing my picture. I'm going to name mine, well, I have only P's and Q's. What do you think my third letter I should use is? R sounds good. Why'd you pick R? Yeah, it's the next letter in the alphabet. Could you have used O? That's the letter before P. You could, but God, I hate using O as a variable. Why? Looks like 0, doesn't it? Yeah, that's, ugh. Never gonna do that. Everybody's okay? All right. So then I'm gonna name or label my side lengths. So P, Q, and R. I'll write in my givens. Now let's figure out which situation we're in. Let's see. So we have angle Q. We have angle P. And we have side Q. Which situation was this? Angle, angle, side is correct. Again, that tells us we need to be doing the law of sines. So let's write down what we need. We need angle R, we need side R, and we need side P. So far, so good. Which of the three should I solve for first? Angle R. How do I find angle R? Yeah, so 180 minus 80 minus 43. So that should be 57. Does it matter which side I solve for first, P or Q? Nope. For these, when we have two angles, it doesn't matter the order in which we do things. When we have two sides and one angle, the order matters, unfortunately. And when we have three sides, the order matters, unfortunately. The order we find angles matters. I know. All right, which let's say we solve for side R first, because I wrote the R first. No better reason than that. All right. Which letter am I going to use to solve for R, P or Q? Not P. Has to be Q, because Q is the one where I know both the angle and the side. Do I know both the angle and the side for P? I do not. So I'll write sine of 80 over 7.3 equals sine of R, 57, over R. We'll cross multiply and divide. Is it okay if I just skip that and write it as one step? Nobody objects to me doing that. We've done it a couple of times. It's a pretty easy combining of two steps. I wouldn't do it the first time, but after we've done it a couple of times, I don't feel too bad about doing that. So I'll go to my calculator and type this in to get myself a nice decimal. So there's about 6.22. I think these were centimeters. So now we'll solve for P. Again, to do that, I'm going to use angle Q and side Q, because I'd prefer to use the givens than stuff I had to come up with on my own, just in case I like fat fingered a button or something and typed something in wrong and ended up with the wrong answer. I don't want that. So I have sine Q over side Q equals sine of angle P over side P. Again, we'll cross multiply and divide. And it's calculator time. Let's move it over here so everybody else can see. So I get about 506. And before I say I'm done, let's check my picture here and make sure everything matches up. Is the big angle across from the big side? Yes. Is the medium angle across from the medium side? Yes. Is the small angle across from the small side? Yes. I'm pretty confident then that I have the correct answer. Not sure, but pretty confident. What do you guys think? This is where we're going to stop for today then, if you guys feel okay. What I'm going to ask you to do for Sunday's problem set is just problems 1 through 4. That'll be the only thing due this Sunday. What we do on Friday wouldn't be due until the Sunday after we get back from break. So I'd rather load the homework at the start of break than at the end of break, right? Get it done this weekend, and then you can just not think about math any more than you do on a regular basis until we get back to school. I mean, I think about math every day, but, you know. Yes, sir. Sure. It's like that meme about men in the room. How often do you think about the Roman Empire? The answer should be every day, you know. No, you don't know that one? You seen that? Yeah. You've all seen that. Good, good.